Okay, so good day. So this time we are now on the module 4 of quarter 10, illustration of sector, segments, secant, and tangent of a circle, and we have to prove theorems on secant, tangent, and segments with the code M10 GE-11 E-F-1. So after going through this module, you're expected to illustrate sector and segment and find the area of sector. So let us review first. Central angle. So a central angle is an angle where the vertex is on the center of the circle. So the measure of central angle is equal to the measure of its intercepted arc. Okay, so if arc DB, the measure is 50 degrees. So therefore, angle BPD is also equals to 50 degrees. And the measure of angle DPB is congruent or equal to the measure of arc DB. While in scribe angle, the measure of scribe angle is 1/2 to the measure of its intercepted arc. So the scribe angle, the vertex is on the circle. And so therefore, if the measure of arc LB is equal to 120 degrees, then the measure of angle LOB is equal to 60 degrees. That is 1/2 of its intercepted arc. And therefore, the measure of angle LOB is equal to 1/2 of the measure of arc LB. Okay? So what is the degree measure of one revolution of circle? Okay, so it's correct. It is 30 or 360 degrees. So one revolution of a circle is equivalent to 360 degrees. So if a circle A is divided into 8 congruent arcs, as shown on the figure, so that is divided into 8 congruent arcs. So what is the measure of its arc? Okay, very good. So it's 45 because if we divide 360 by 8 is equals to 45 degrees. And so therefore the measure of its arc is 45 degrees. So what is the ratio of its arc to the circumference of a circle, or to the entire revolution or one revolution of a circle? So how to compute that? So it can be 1/8, or the ratio, to find the ratio is 45 degrees over 360 degrees equals to 1/8. So the ratio of its arc is 1/8 of the entire circumference of the circle. Okay, so for example, given circle A with radius equals to 6 units, find the area and the circumference. So this time we're going to review on how to find the area of circle and the circumference of the circle. Okay, so we have that circle A with radius equals to 6 units. So can you recall the formula for the area of circle? Yes, it is A equals to pi r squared, where r is the radius. And so therefore, the area of that given circle is equal now to pi 6 squared, or equal to 36 pi. From 6 squared is 36, then pi. And the approximate value of pi is 3.1416. So multiply to 36. So the area now of a circle is approximately 113.1 centimeter squared. How about for the formula of the circumference? Okay, very good. So the formula for the circumference is 2 pi r. So substitute for the value of the radius. So we have now c equals to 2 pi 6, where r is 6, and you multiply 2 times 6 equals now to 12 pi. Then multiply to the value of pi, which is approximately 3.1416. So therefore, the circumference is 37.7 centimeter. Okay, so that is the formula for the area and circumference of the circle. So we review this because we are going to use this formula as we go on with our discussion on the sector and segment of circle. Okay, so now let's talk about sector and segment of circle. Okay, so we have circle A with that shaded region bounded by a central angle, TAM, and arc, the intercepted arc, EM. Okay, so that figure with shaded region bounded by angle TEM and arc EM is called a sector. So a sector of a circle is the region bounded by an arc of the circle and the two radii, this radii EM and AK, to the endpoints of the arc or the intercepted arc EM. So that is an example of sector. So therefore, the shaded region with color orange bounded by central angle KEM and arc EM is a sector of circle A. Okay, so don't forget that the sector of a circle is bounded always by a central angle and its intercepted arcs. So let's have another figure. So we have circle A with chord PR. So that is called the segment of circle. So a segment of a circle is a region bounded by an arc and the segment joining its endpoint. So it means that it is a region of or a part of a circle bounded by a chord, you know, and the two endpoints of the arc. Okay, so the shaded region with color maroon bounded by chord PR and arc PR is a segment of circle A. Now, on exercises. So, which of the following is or are sector or segment of the given circle? So, what do you think? Number one, is that segment or sector? Okay, very good. That is segment because it is bounded by a chord and the arcs. How about number two? Okay, correct. That is sector bounded by the central angle and the arcs. How about number three? Yes, of course, that is segment. Number four, okay, that is sector. How about number five? Also a sector. And number six is a segment. Okay. So let's talk now about the area of sector. How to find the area of sector? Example, given circle T with radius equals to 8 centimeter divided by 6 congruent arcs. What is the area of the given sector as shown on the figure below? So we are going now to find the area of this sector bounded by angle CTB in the arc CB, this shaded region. Okay, we have step one. Determine the area of the given circle. So if the radius is 8 centimeter, So using the formula for the area, which is equals to pi r squared. So therefore, if the given r is 8 centimeter, we have now the area is equals to pi 8 centimeter quantity squared, or the area is 64 pi centimeter squared. So we can write our answer up to this equation only. But we can still simplify by multiplying the value of pi, which is 3.1416. Then we have step 2. Determine the measure of an arc of the given sector. Okay. Since the circle is divided into 6 congruent arcs, then we have 360 degrees divided by 6. So equals to 60 degrees. So therefore, the measure of each arc is 60 degrees. And the measure of arc CB is 60 degrees. Okay, so step 3, determine the ratio of an arc of a sector to 360 degrees, or one revolution of the circle. So what is now the ratio of 60 degrees to 360 degrees? So of course, it is 1 over 6. So to find the ratio, it is equals to the measure of an arc over 360 degrees, equals to 60 over 360, or it is equals to 1/6. So the ratio is 1/6. So it means that the area of that sector, which is this shaded region, is 1/6 of the area of the entire circle, or equals to 1/6 of 64 pi centimeters squared. So, so that we solved before, or equals to 32 over 3 pi centimeters squared. Simplify, so equals now to approximately 33.5 centimeter squared. Okay. So the area of sector, or we have this formula, the area of sector is equal to the measure of arc over 360 times the area of circle. Okay, so let's have now our exercises. Find the area of sector as shown on the figure below. So we have circle T with radius equals to 12 centimeter, or 12 units. And we have arc AB, which measures 120 degrees. So, so we have that given. The radius is 12 centimeter, and arc AB is equals to 120 degrees. Since we have now the formula that area of sector equals to the measure of arc over 360 degrees times the area of circle. So we have now 120, the measure of arc, over 360 degrees times pi r squared. So we have pi 12 centimeter squared, or 120 over 360 is one third by simplifying. And 12 squared is 144 pi centimeter squared. Simplify. So multiply 1 times 144 divided by 3 is 48 pi centimeter squared. And then if we multiply 48 to 3.1416, the value of pi, so we have now the approximate area of that sector is 150.8 centimeter squared. So the area of sector bounded by central angle ATB and arc AB is approximately 150.8 centimeter squared. Okay, so that's how to solve. Okay, so let's have another one exercises. So given circle O with radius or with diameter RP equals to 10 centimeter, find the area of sector bounded by arc RS if arc SP is 150 degrees. Okay? Since RP now is diameter, which is equals to 10 centimeter of circle O, and the measure of arc SP is 150, then therefore the measure of arc RS is 30. Okay? So if SP is 150, so RS is uh, 30 degrees because RP is diameter. So the diameter divides the circle into two semicircle or congruent arcs, congruent parts. So let's substitute now. So our radius now is equals to 5 centimeter. Okay. We have 30 over 360 times the area of circle, which is pi r squared, where r is 5. So simplify. So 30 over 360 is 1 over 12 times 5 squared is 25 pi centimeter squared. Or it is approximately now to 6.5 centimeters squared by multiplying 1 times 25, which is equal to 25 over 12, is 6.5 centimeter squared. So therefore, the area of sector bounded by central angle ROS and arc RS is approximately 6.5 centimeter squared. Okay, I think that's all for this episode. So on our next episode of our video lesson, we will talk about the area of segment.